Hello everyone. If it's all right with you, I might do a bit more chemistry if that's all right. Thank you very much. Thank you. Right. I just want to show you this now. Um, right. If I just show you this here, that, like that, and then I'll explain it to you. The the hadrons. The bions derive from the hadrons. So the bions come from the hadrons. And that's spelled Hadrons. And the bions is spelled Baryons. And the bions are composed of three quarks. Examples of baryons are the protons and the neutrons. And now I just want to show you some elements that I've written down on the periodic table. Chromium there, chromium. That's chemical symbol is Cr. And on your right, on my left, I've got the neutral atoms here. So I've written down there's 24 protons, the atomic number, or 24 protons. And then I've written the energy levels, which are the electrons. So 2, 8, 13 and 1 are chromium. And there are 4 energy levels for chromium. Just thought. The atomic number is 24. Neutral atoms, as we know, have the same amount of electrons as they do protons. And the energy levels obviously reiterate of 2, 8, 13 and 1. That's chromium. And that adds up to the same atomic number, which is 24. And the relative, there are 28 neutrons, and the relative atomic mass is 52 for chromium. And then below that is tungsten. Its chemical symbol is W, and there's 74 protons and 74 electrons in neutral atoms, because they're not ions, so they'll have the same number of electrons and protons. And there are 110 neutrons for the tungsten, so that gives it 184 relative atomic mass of 184. I've got zinc here, and that's Zn, the chemical symbol. It's 30, atomic number is 30, and the same number of electrons, but they've got... So they've got 4 energy levels for my zinc, for the zinc atom for the electrons, and 35 neutrons gives it 65.4 number relative atomic mass number. And then I've got silver down here at the bottom here. It's got an atomic number of 47. And then it's got 5 energy levels, silver has. 2, 8, 18, 18 and 1. And its chemical symbol is Ag, so big A, small g. And I've rounded this one up to 108 because it's actually 107 point... Silver relative atomic mass is 107.8 or something like that. So I've rounded it up to 108. So it's got 61 neutrons there. And 47... electrons and then 47 protons. So the atomic number is 47, and then the energy levels of the electrons. And for silver, there are 5 energy levels in neutral silver atoms. 5, 2, 3, yeah. And then up here, I've got cadmium, and its chemical formula. Its chemical symbol is Cd. So it's a big C and a small d. And it's got an atomic number of 48, cadmium, yeah. And it's got 5 energy levels for the electrons. 2, 8, 18, 18 and 2. And it's got 64 neutrons, so it's 112 relative atomic mass. The mass number is 112. And then mercury, its Hg chemical symbol is Hg. It's got 80 protons and 80 electrons, and 120 neutrons. and that gives it a relative atomic mass is 200.6. And then I've got iodine here, and iodine is it's a halogen, and when it's an ion, first of all, I'll just mention this. It's got 53 in a neutral atom. Iodine's got 53 electrons and 53 protons, and it's got 74 neutrons. So its relative atomic mass is 127, and obviously iodine has got energy. It's got 5 energy levels: 2, 8, 18, 18, and 7. And when it's an ion, it gains. When it's a neutral atom, it's got 53 electrons. But when it's an ion, it's got one more electron. So it's got 54 electrons with a -1 charge. So I just thought I'd mention that to you. So the 5th energy level for the neutral atom is 7, and for the ion, iodide actually, it's spelt differently. For the it's got it goes up to 8 in its 5th energy level. So from 7 to 8. So I just thought I'd show you that. Thank you for that. And on the other side, I've got carbon, and carbon's got 6. Carbon's got 6 for its atomic number, for its proton number, and its configuration is 2,4 for its electrons, and it's got 6 neutrons, so it's got a relative atomic mass of 12. And then I've got germanium there. Well, carbon's got C, so its chemical symbol is C, and I've got germanium there, which is chemical symbol is Ge, and it's got its proton number or atomic number is 32, and it's got 32 electrons, and it's got 41 neutrons, so it's got a relative atomic mass of 73. And then I've got lead here. So lead's got 82 protons and 82 electrons. It's got 125 neutrons, so it's got a relative atomic mass of 207. 207, that's right. Sulfur here, its chemical symbol is S. It's got, in a neutral atom, it's got 16 protons and electrons. And obviously, when it's an ion, it's still got 16 protons. And then it gains 2 more electrons with the sulfur ion. So it's got 18 electrons in its ion as opposed to 16 in the neutral atom. Anyway, so if I talk about the weight is 16 protons and 16 neutrons, gives it a relative atomic mass of 32. So the mass number is 32. Fluorine here, that's in a neutral atom, it's 2,7. It's got 9 electrons and 9 protons, and then it's a halogen. So it actually its second energy level has 8 electrons when it's not a neutral atom, and that's right, and it has a -1 charge, like all the halogens have. And anyway, but going back to the neutral atom here, so 9 protons and 9 electrons, 10 neutrons gives it a relative atomic mass of 19. That's the fluorine atom. And then bromine here, I've got the ion, not the ion, the neutral atom, because the ion's 36 electrons, but the neutral atom's 35 protons and 35 electrons. And it's got 45 neutrons, gives it a relative atomic mass of 80. And the isotopes for bromine are 79 and 81. And as you know, 35, they both have same numbers of protons and electrons, which are 35 for the isotope of bromine's 35. And then you've got 44 neutrons for the 79 for bromine 79. And for bromine 81, you've got 46 neutrons. So you're 44 for 79, isotope 79 and isotope 81, 44 neutrons and 46 respectively. There, just written it. It's probably the best way to see it, sometimes written down. And copper here, which has got the chemical symbol is Cu, and it's got in. I've got some isotopes here for copper. They're not the element on the periodic table, but I've got the two isotopes. I think they're stable. I'm not sure. I think they are, and I think isotopes of bromine, those 79 and 81, are stable. I think they are. So I don't. I'm not sure. I think I'm right there. So I don't want to say something that's wrong. But so copper has 29 electrons and 29 protons, because the isotopes have the same number of electrons and protons, and they just they just differ with their neutrons. So the copper there is 34. Copper, one of them's 34, one of them's 36, with 34 neutrons and 36 neutrons. And then you've got the relative atomic mass, or the mass number. One of them's 63 and the other one's 65. So I just thought I'd show you that. And then I've got platinum here, which is the chemical symbol is PT. And I've got 78, well, as you know, neutral atoms, 78 protons, 78 electrons, and 117 neutrons, gives it a relative atomic mass of 195. I've got boron here as well. And boron in a neutral atom, 5 electrons, 5 protons, and 6 neutrons. I'm rounding it up, I think, to 11, because I think it's 10.8 or something. So I'm rounding the boron atom up to 6 here. Because sometimes you round it up or round it down. It's not always exact or precise. It's approximately with this. So you could, if you consulted your science books, you could say, oh, that's slightly wrong, but actually it's just approximate. It's not exact or precise. So they round it up and round them down, the relative atomic mass. And it's the neutrons they tend to, approximate. It's approximately. And I've written down some inert noble gases. I've written down some noble gases, or the inert gases, and they're either on your periodic table. Can be group 8 or group 18 or group 0. So you have 3 options there. So that's a bit strange, isn't it? But yeah, you've got 3 options for the group of 8, 0 and 18. Anyway, helium is He, chemical symbol. It's got 2 protons and 2 electrons and 2 neutrons. Gives it a relative atomic mass of 4, because 2 protons and 2 neutrons makes it 4. And the alpha particles resemble helium, because they're the most effective at knocking off electrons off atoms, because they're the heaviest, aren't they? When I was talking last time about alpha, beta and gamma, and it's in that order actually. Alpha is the most effective at knocking electrons off atoms, and then it's beta, and then it's gamma. But they all have this ability. They're all powerful enough to knock electrons off atoms. So I just thought I'd mention that. Argon here. Argon is Ar, and it's that's the chemical symbol, and it's argon, Argon, and it's got 18 neutral atoms, 18 protons and 18 electrons, 22 neutrons. Gives it a relative atomic mass of 40. And then I've got neon here, and its chemical symbol is Ne. It's got 10 protons, 10 electrons, and 10 neutrons. So it's got a relative atomic mass of 20. So I just thought I'd show that to you. Right, so I just thought I'd show that to you. Thank you for listening to me. Right, I just want to show some other things now. Sorry, just thank you. Thanks for being patient with me. Right, I just want to do some other things today, so I'll just write this. Sorry, thank you for this. Thank you for being patient anyway, but I just want to show you this. Now, I'm just going to write some things down now. Thank you. Thanks for this. H equals 1, N equals 14, O equals 60, S equals 32, and H 4, 2, S, O, 4, plus 2 times 40 plus 8 times 1 plus 32 times 60. Right, just writing NH4 2 times plus times 32. I just wanted to show you this here. Some chemistry sums, if you like. They're sort of to help you here. Hydrogen is relative atomic mass of hydrogen is 1. The relative atomic mass of nitrogen is 14. And I've done the chemical symbols here, as you know. And oxygen equals 16, relative atomic mass. Sulfur is 32, relative atomic mass. And I've just done some little sums here. So NH4 in the bracket, and so you've got obviously 8 times 1 is for the hydrogen, and then you've got 2 times 14 is 28 there. Sorry, and obviously sulfur is 32, and you've got one atom of sulfur there. So when there's nothing there, it's interpreted as 1. And then you've got 16. Relative atomic mass of oxygen is 16. And then you just say 4 times 16, because obviously there are 4 atoms of oxygen there. So you just times the 4 by the relative atomic mass of oxygen. So I've just put them. So they're all up there, the relative atomic mass. You've got sulfur, which is 32, oxygen is 16. So I just wanted to help you here. That's show you what it's about. Thank you for that. Thanks. So that's sulfur there. Sorry, that's very kind of you. Thank you. Thanks. So if I just right, I just do. I'm going to just write out this now. I've got uranium here. Its chemical symbol is U. So I've just written out uranium there, and I think that's the one on your periodic table. And it's got uranium 238. So it's got a relative atomic mass. It's radioactive. It's got a relative atomic mass of 238. It's got 92 in a neutral atom. It's got 92 protons and 92 electrons, and 146 neutrons. So that gives it a relative atomic mass of 238. So the mass number is 238. So I just thought I'd show that to you. Write some sums down today. Not sums, but yeah, just some things like that. And I'm going to write out this now. The one at the top is calcium carbonate. I've just written calcium carbonate at the top there, and it's got Ca. So that's a big C, small a. So it's a lowercase, I think, a. So I think it's a small a there. It is a small a for calcium. And carbonate is CO3. So it's got one atom of carbon and 3 atoms of oxygen. So I just thought I'd write that down for you. And then the magnesium carbonate is Mg, because the chemical symbol for magnesium is Mg. And then carbonate, CO3. So it's 1 atom of carbon, 3 atoms of oxygen. So I just thought I'd help you there a bit. And I'll just write this out now. Just write something else now. C12O6V Mg24. Right, I've just written relative atomic mass at the top here. So I've got the 12 for carbon, 16 for oxygen, and 24 for magnesium, the chemical symbols and their relative atomic mass. And then I've just done a magnesium carbonate. So you've got there MgCO3. So 1 atom of carbon, 3 of oxygen. And obviously 24 is the magnesium, the 12 is the carbon, and then obviously oxygen, 3 atoms of oxygen, so that's 16 times 3. So that gives the number 84 there. Thank you for your patience today as I'm writing these sums out for you. Thank you. Thank you very much. Thanks for that. I'll just write something else down there for you. Thank you. Right, oxygen. Right, so I'm just going to write oxygen, and then I'm going to put here. It goes like. The transformation, I've got the transformation here of oxygen going to oxide, iodine going to iodide, and sulfur going to sulfide. So it's sulfur, and then it's got, so SULPHUR goes to SULPHIDE. So I just wanted to show you that. Thank you for that. And then if I just, thanks for letting me do this, thanks. If I just put, right, OH here is hydroxide. Na is sodium hydroxide. SO4. So again, OH is called hydroxide. So we've got sodium hydroxide there. Na is the chemical symbol. And SO4, so that's 1 atom of sulfur, 4 of oxygen, is called sulfate. And copper sulfate. I've got copper sulfate there. The chemical symbol for copper is Cu, as you know, and SO4. That's copper sulfate. So I just thought I'd show that to you. Thanks for waiting. Thanks for that today. Thank you for that. And if I just... Another thing I'd like to talk about today, before I wrap things up today, is something else I'd like to talk about. Right, I just want to talk to you about cations again, the cations. So with silver, it's Ag. If I just put here, sorry, thank you for this. Ag plus. That's silver. That this chemical symbol is silver. Ag plus, and the cation loses its fifth energy level. So actually loses. So it's the neutral atom has 47 electrons and 47 protons, and then the cation goes to it's Ag plus. So it actually it loses an electron with a 1 plus. So it goes from 47 to 46. And as you know, the atom starts off at 47, the silver atom, and then it goes to 46, and then it reverts back to 47. As that's what happens with the metals in electrolysis. They gain their electrons. So they start off with 47. They go to 40. Well, if I'm looking at silver here, 47. It loses its fifth energy level, goes to 46, and then at the end of the electrolysis process, it goes up to 47 when the cations are attracted to the cathode, which is the negative electrode. So I just thought I'd show that to you, say that to you. So when I was talking about electrons and ions on one of my other talks, so that's what I was talking about then. So yes, I just wanted to write something else down for you today. Just write this down. NaH. Right, I've got sodium hydroxide there. Maybe I haven't written it as clearly as I should have done. But sodium hydroxide there, and sodium carbonate there. So, sodium carbonate is Na2CO3, Na2CO3, sodium carbonate. And sodium hydroxide is NaOH. NaOH, sodium hydroxide. So I've just got that there. So I just thought I'd show that to you. And I just want to write another sum down now. Thank you for being patient today. Right. I just want to write this down here. Just want to show you what this sum actually develops into. It's sort of want to show you that. Sometimes, if you look at it, I don't always have to explain everything. You know, that calcium and the CO3, one atom of carbon, three of oxygen, plus H2O, plus CO2, which is carbon dioxide, as I'm sure you know, and the arrow goes to calcium, HCO3 in the bracket, and you've got 2 outside the bracket. So I just thought I'd show that to you today, so it just makes things clearer for you. And if I write some chemistry questions and answers down, and you might actually, if you're not sure about something, I may have solved some problems for you. I don't know, but anyway, I just wanted to write that down for you. Thank you for waiting for me like that. So, one more thing I'd like to say before I wrap things up today. I just want to say that zinc, when it's got a +2, it's a transition metal, and it's got a +2. It loses its 4th energy level. So zinc 2, Zn, I think, is the chemical symbol Zn, and it's +2. It actually, when it's +2, as you know, it loses 2 electrons, and it loses its 4th energy level. And then it obviously, the ion goes atom, ion, atom, because it always it reverts back to its atom again. And that's why you've got metals gaining their electrons at the end of a process, and non-metals losing electrons to go back to the neutral atoms. So that's the cycle, if you like. Copper plus, which is just copper +1, that's from 29 electrons to 28 electrons. So it actually it loses its 4th energy level. Copper loses its 4th energy level when it's copper +1. Copper 2 plus goes from 29 electrons to 27 electrons. As you know, 2 plus means it's gone from 29 to 27. And so the configuration for the iron is 2817. And the configuration for the copper +1 is 2818. So I just thought I'd share that with you. And if I write it down, you might want me to write it down. Cu plus 28, 2, 8, 18, and then Cu2 plus 2, 8, 17, 20. So it loses its 4th energy level on the Cu plus, loses its 4th energy level. So it's 2818. So it's only got 3 energy levels there. And the copper 2, so copper 1 goes from 29 to 28. Copper 2 plus goes to from 29 to 27. So that's 2817. So that's the iron configuration. So I just thought I'd show that to you. And one more I want to do now, and then I'll say goodbye to you, is iron. Iron actually can form Fe2 plus and Fe3 plus. So it's it goes from 26 electrons down to 24, and on the other one, 3 plus, it goes to 23 electrons. So if I write the iron configuration down for the iron, not the 10, it loses its 4th energy level. Iron 2 plus loses its 4th energy level, so it's 2814. And then 2 on the 4th energy level that goes. So and then for iron, the chemical symbol is 3 plus. For Fe3 plus, it goes from 26 electrons to 23 electrons. So it has a iron configuration of 2, 8, 13. So, yeah, that's sort of how it works. So I thought, I know I've done a lot of writing today, more writing than talking, but I just thought, I just wanted to help you with some of the, the mathematical side, maybe. I don't know, something. Anyway, so Fe2 plus is 24 electrons, and it knocks off that fourth energy level. And so Fe2 plus and Fe3 plus only have 3 energy levels, not 4. Anyway, I thought I'm sure you've, read enough about maths, chemistry sums today. So anyway, thank you very much for being so patient with me today. And if you could subscribe to my channel, that would be very kind of you. That would be very, very nice of you. Anyway, all the best. Thank you. And I hope I've solved some of your chemistry problems today. Thank you very much. Thank you. Bye.